Hi, my name is Abby McCullough, and welcome to my presentation about Donald Knuth. So, one of my favorite quotes that I've seen of his so far is, "The best way to communicate from one human being to another is through story." And that is something that I think will make sense a little bit further on through the presentation. But first, we need to figure out, so who is David Knuth? Well, he was born and raised in Milwaukee, Wisconsin as a German Lutheran in 1938. He got his undergrad in physics at the Case Institute of Technology and his PhD in mathematics at the California Institute of Technology, otherwise known as Caltech. He taught at Stanford for over 2 decades, and he's actually still giving lectures there, one of which is his Computer Musings course. It's available next semester in 2025. So a little bit about him in his earlier life is Knuth actually won a contest in the 8th grade using an algorithm that he devised. He did a lot of his early work with the Berghoff Corporation, which is an American manufacturer of business equipment. Some of the things he worked with was the ALGOL, which is short for algorithmic language. It's something that we base a lot of languages off nowadays, like B, Pascal, C, and others. He worked with this to make a compiler for the B205, and then also worked with others in the company to work on other B computers. He's also known for the man or boy test that comes from this, which is a test that if people can correctly implement recursion and non-local references in terms of AGLOL's 60 implications. He wrote a Frontron compiler. He said he sold his soul to do this. And he's, of course, most widely known, I think, for his publications of the art of computer programming. He's also done a multitude of other things, like his work with TextX and Metafront. He's received the title of Professor of the Art of Computer Programming, and this has later been revised to the Professor Emeritus of the Art of Computer Programming. So that might seem like a lot, but in some of the later slides we'll dive deep into what this actually means and who he is. So one thing I mentioned on the last slide was the art of computer programming. And so the art of computer programming was something Knuth wanted to write because back in the time when he was writing this in 1968, computer science wasn't even defined as a science yet. So this kind of opened up the doorway to what computer science was, what computer programming was, and a doorway for people to learn how to get into it. For many, this is held as the Bible for base computer programming. It was originally only supposed to be one volume, but because of the contents of it, they decided it'd be better to split it up and expand it into 7 different volumes. Currently, it is still being produced. They're only on volume 4. Some of the things in volume 4 include 4A, 4B, and some facils. I think up to 8 facils. Volume 5 is actually expected to be released in 2030, and one of the reasons that Knuth decided to retire as a Stanford professor was because he said he needed over 20 years of work to create this whole publication in its finality. But this is far from the only thing that Knuth has ever publicated. One of the expansions he actually did off of the art of computer programming was the Concrete Mathematics, a foundation for computer science. When he was making his original publication, he saw, based off his PhD in mathematics, that there was a lot of base mathematics things that computer scientists needed to know. And so he decided to make this expansion. Based on his religion, he also decided to make a book, The Things a Computer Scientist Rarely Talks About. And more on the fun side of things, he actually made a publication for Mad, the kind of famous comical novel. Kind of going off that humor front, Knuth is one who's really, he's in it for the science, he's in it for the learning. And so he actually has a thing where if you can find an error in any one of his publications, any one of his books, you can win one hexadecimal dollar, which is $2.56. He actually has a page on Stanford, on his page about him. He has a whole list of his books and all the known errors that have been found. He has a list of people who have actually won any and all money from this. He used to send out checks for these, but he actually got into a little bit of bank fraud because of that, because of people stealing his name. So now he has this bank of domination where you can see who has won and who actually owes money. So he still does send out this money in a sense, it's just slightly different. So when the Art of Computer Programming was actually being released, they were currently using mono typesetting and they upgraded it to photo typesetting, but Knuth really wasn't happy with this process at all, so he decided to make his own digital typecasting, which was called TextX, and he made TextX and Metafont, and they work together. So TextX is a cross-platform typesetting program that is popular for typesetting complex mathematical formula. And of course, it replaced that photo typesetting and the monotype setting, which was technically called hot metal typesetting, is what the type of typesetting monotypesetting used. That's a lot of typesetting in a sentence. It was developed by Donald, and what Metafont did is Metafont is a descriptive language used to define raster fonts, so it looks at the glyphs. So Knuth is actually known as the father of the analysis of algorithms, and as you can see on the left-hand side here, I think he well deserves that title. Back when he was actually developing TextX, Knuth wanted to create a new methodology of programming, which is called literate programming. And basically what the purpose of this was is he wanted programmers to think of programs as works of literature. So kind of what you can see here is he wanted to create the idea of these algorithms, making the story. And one of my favorite quotes from this was, instead of imagining that our main task is to instruct a computer what to do, let us concentrate rather on explaining to human beings what we want the computer to do. So what he did with this is he embedded this idea, that quote, into this thing called the web system, right? And what he did is he used the same iteration of the system to make a C web system. And what this is, this replaced Pascal with some of the languages we know now as C#+, and Java.